So another little system we've done. This is a 222, Wiesmann 222 with two mixed circuits, no unmixed circuits. It's radiators upstairs, underfloor downstairs. But doing the calculations, the radiators upstairs would be running over output if they were an unmixed circuit when running at the same temperature as the underfloor, and especially on night setback. So we're unable to use a unmixed circuit. So what we've done is we've done a few little calculations here, taken the heat loss of each room, added them together to get the zones, and come up with the final figure of the flow rates in cubic meters an hour. And we've done that because we have some kind of guidance on these pumps. Now, we've not done the fine level balancing on here, but to start with, what I've done is set these as close as I can to, so these have only got in increments of 0.1 cubic meters an hour. So I've set it to the setting just slightly higher. So where I need 1.5, for example, I've set to 2, and where I need 0.85, I've set to 9. So it's slightly higher head than required, slightly higher flow rates on both circuits than required. And that would allow us, as we go around, to balance up and make our adjustments. We'll lose a bit of flow off of those pumps. Now, it does give us also the consumption in watts, and that also allows us to make a judgment, in meters head as well. Now, with a meters head, we can make a little bit of a judgment of where we might be between the tenths of a cubic meter per hour reading, so we can have a little judgment of that. But we're going to get fairly accurate balancing by going through this. This is an ambient manifold. Now, I've started to use ambient because they have a guy there who seems to understand the design criteria needed for underfloor heating quite well, and gives us access to him. So we've got a set of flow rates to set on these that will allow us to have different delta T's in each room to compensate for the static positioning between the pipes. So where we've got 150 mil spacings between the pipework, then what we can do is increase or decrease the flow slightly to change the average surface floor temperature to correct the slight inaccuracies and floor output. And this is all designed to avoid the use of room stats. So we should be able to match very accurately the output of any floor without using any actuators and room stats. So we can make some fine adjustments on this. We've done it many times before, to be fair, but we've done it in the past by trial and error rather than by calculations. So we've been retrofitting on systems mainly and adjusting the flow rates to get the right temperature outputs. And to be fair, it's normally within 1 degree anyway, even when we don't bother. So sometimes I wonder if we've been a little bit overzealous trying to follow all this theory through. But if we know what we're doing, we should try and exercise it, I think. So anyway, these are the pipes coming down from upstairs. They feed into the low loss header from the 222. Then that's my distribution header across there, and drop down into these mixers. I quite like this layout we've done here. It's quite neat and tidy. And I've got another video which features this one. So now this one, interesting enough, it's got the non-return valves on the circuit side, and I'm interested to see if this gives a problem. I know somebody else on the forum recently did the same, and found that when the system went into cool down, these mixing valves lock closed, and that there's such a good seal on them that it seals this circuit completely, and that's with hot water. So as that water cools down, we get a negative pressure, and you got quite a drop on there. Now also we're trying to find out why we need the non-return valves in the first place. So if anyone's got any ideas, please let us know. I've got another system I've done where I've put them on the other side. So on the return legs, I'm not sure if that's going to give us a benefit. So I spoke to Wiesmann Technical. They don't know why they're there. I've had several theories and I've given up. I can't quite work out what the point is. I thought for reverse circulation, but I can't see how we're going to get that. It would only make sense if these valves didn't close. So if you had those open but pump off, then you could get some reverse circulation going off. But that doesn't happen. These valves close when the pumps go off. So if they're closed and the pump is off, they've already sealed that circuit. So I guess the only other justification for them is if you think you might have poor quality valves which allow some seepage, but these, they're very tight enough to hold a vacuum. So maybe they shouldn't be. Maybe that's the problem. Maybe the valves are too good. So anyway, anyone got any more information on that, can give me any feedback, I'd really appreciate it. I'd like to understand what the valves are there for. The latest one I'm doing, I haven't put any in at all, and I'm just going to see if we can see any difference, see any problems, identify what it is they're there for. So okay, well, there'll be some more videos to follow on this one, but for now I hope that helps.